MS Ramaya University of Applied Sciences.
Hi students, let us have a discussion on bridge rectifier circuits. The aim of this experiment are to observe waveform at the output of bridge wave rectifier with and without capacitor filter and to calculate ripple factor of a bridge rectifier. Motivation to this experiment. It makes electrical power useful for electronic and medical equipments. Rectifier circuits are used in chargers, UPS, etc. Let us understand the theory behind the experiment before conducting it. Bridge rectifier uses 4 individual rectifying diodes connected in a bridged configuration to generate the desired output, but does not require a special center tap transformer, thereby reducing its size and cost. The 4 diodes labeled D1 to D4 are arranged in series pairs with only 2 diodes conducting current during each half cycle. Capacitor converts the full wave rippled output of the rectifier into a smooth DC output voltage. To conduct this experiment, we need step-down transformer of specification 606/909, resistor of 1 kilo ohm, diode models of 1N4007, capacitor of 100 microfarad, oscilloscope, breadboard, probes and connecting wires. Figure shows the circuit diagram of bridge rectifier without filter. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect probes of an oscilloscope across the load resistor to see the output waveform. Note down the peak value of the output waveform for further calculations. Figure shows the experimental setup of bridge rectifier without filter. It shows the experimental result of bridge rectifier without filter. Figure shows the circuit diagram of bridge rectifier with filter capacitor. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect probes of an oscilloscope across the load resistor to see the output waveform and across the transformer to see the input. Note down the peak value of the output waveform for further calculations. Figure shows the experimental setup of bridge rectifier with filter capacitor. It shows the experimental result of bridge rectifier with filter capacitor. Here, output is closer to smooth DC signal with much lesser ripples.
Hello students, aim of the experiment is bridge wave rectifier. Aim of the experiment is to observe the output waveform of a bridge wave rectifier with and without capacitor filter, and also to calculate the ripple factor of a bridge wave rectifier with and without capacitor filter. Components required for the experiments are step down transformer. This is a step down transformer. Its primary windings are connected to the main supply and its secondary windings are connected to the circuit of a bridge wave rectifier. Digital oscilloscope. This is digital oscilloscope which is used to observe and measure the output voltage of the bridge wave rectifier. Breadboard. This is breadboard. It is used to connect the circuit components of a bridge wave rectifier. Resistor. This is the 1 kilo ohm resistor having a color code of brown, black, red. 4 diodes. These are all the IN4002 diodes which has 2 terminals. One is called P, one more is called N. In this, the terminal which is encircled with a silver color ring, that is called N side, and another terminal is called P side. Capacitor. this is a capacitor having a value of 100 microfarad. Here it has positive terminal and negative terminal. The terminal which is indicated by a black strip with a negative sign is called negative terminal, and other terminal is called the positive terminal. Connecting wires, these are connecting wires which are used to connect the different components on a breadboard. And probes, these are the probes which are used to connect a digital oscilloscope to the circuit output voltage. Let us begin with the circuit connection of a bridge wave rectifier without filter based on the circuit diagram. First we connect diodes in a bridge form based on circuit diagram. Let us take a diode 1. This is the P side of the diode 1, this is the N side. Connect somewhere in the breadboard like this. Take one more diode, let us call this the diode 2. Diode 2, P terminal is connected to the N side of the diode 1. So, I will connect its P side to the N side of this diode, and diode 2 N side is connected to the another terminal. Let us take one more diode, let us call this diode as diode 3, where third diode P side is connected to the first diode P side. So, we will connect breadboard like this, and N side of the diode 3 is connected into some new point. We will connect in a breadboard like this. Take one more diode, call this as diode 4. The diode 4 N side is connected to the diode 2 N side. So, we will connect in a breadboard. Now, the diode 4 P side is connected to the N side of the diode 3. Connect. So, now we have connected a diode in a bridge form. Now, we will connect a transformer to the bridge connection of the diode. So, this is a secondary of the transformer which has 3 wires. This black wire is called center tap. We are not using this for a bridge connection. So, these two are the secondary terminals of a transformer. So, one secondary terminal is connected to the one point which is the P and N connection of the diode 1 and diode 2. So, I will connect here on the breadboard, and another terminal of the secondary of transformer is connected to the P and N shorted end of the diode 3 and diode 4, which I connected here like this. Now, primary of the transformer is connected to the main supply. So, this is the main supply. I am connecting to the main supply. Now, take a connecting wire based on circuit. The point which is P type of diode 1 and P type of diode 3 shorted end is connected to the ground. So, I will take a wire and connect in a breadboard, and I will take to a ground line. Let us call this bottom line of the breadboard as a ground line. I am connecting it to ground. Then 1K resistor is connected to the N and N shorted end of the diode 2 and diode 4. So, I will connect a resistor to the shorted end, one terminal. Another terminal of the resistor is connected to the ground. So, this is a ground line. So, I am connecting it to the ground. Let us take a probe. I want to see, or I want to observe the output waveform. So, I will connect this probe to the one channel of the digital oscilloscope, and this probe has positive. This is a positive end, this is a negative end. So, based on the circuit connection, the negative end of the probe is connected to the ground. So, I will take a negative, and which is connected to the ground. So, this is the ground of the given circuit in a breadboard. And positive terminal of the oscilloscope probe is connected to the NN shorted end or a resistor on another end, which is here in the breadboard. I will connect to this point. Now we have finished the circuit connection of a bridge wave rectifier without filter. Turn on the digital oscilloscope. Go to default setup, then press auto set. Now I will turn on the main supply. Once again just go to auto set. Now you can see a waveform on a digital oscilloscope, which is the output waveform of this bridge wave rectifier circuit. Now we will measure the output voltage what we are obtaining here. So to measure that, I will move this waveform on a reference line. If you see this waveform, along y axis it is covering 1 block, 2 block and 3 small division. So 2.6 into each block having a value of 10 volt. So 2.6 into 10 volt equals to 26 volt. This is the output voltage we are getting for the bridge wave rectifier. We will tabulate this value in a given tabular column. Now we have done with the bridge wave rectifier without filter. We have observed the output voltage and also measured the output voltage value of a bridge wave rectifier without filter. Let us start with the circuit connection of a bridge wave rectifier with capacitor filter based on the given circuit diagram. This is the circuit connection of a bridge wave rectifier without filter. If you see the circuit connection of a bridge wave rectifier with capacitor filter, both circuits are similar except there is a capacitor connected in a filter circuit. So I will modify this circuit connection to a bridge wave rectifier with C filter. Before connecting a capacitor, turn off the main supply, and this is a capacitor. Here based on the circuit given in the circuit diagram, so capacitor negative end is connected to the ground. So I will take a negative of the capacitor and connect to the ground in a breadboard. This is a ground line in a breadboard, and positive terminal of the capacitor is connected to the another end of the resistor. So here I will connect this end to the resistor another end. So this wire is not enough, so I will connect somewhere in the breadboard first. And I will take a wire. So this end I want to connect to the resistor this point. So take a wire and connect through the wire. So this end is connected to the resistor, this terminal. Now we are done with the circuit connection of a bridge wave rectifier with capacitor filter. Now connect a main supply, turn on the main supply, and again give a auto set. Now we can see a output waveform of a bridge wave rectifier with capacitor filter. So let us measure the output voltage of the bridge wave rectifier with capacitor filter. So if you see here, from the 0th point, from this line it is covering 1 block, 2 block and 3 small divisions. So 2.6, each block having a value of 10 volt. Again 2.6 into 10 is 26 volt. Let us tabulate this voltage value in a given tabular column. Now we have finished with the circuit connection of a bridge wave rectifier with capacitor filter. There we have observed the output waveform of the bridge wave rectifier with capacitor filter, and also we have measured the output voltage value. Based on those values we will do the further calculation. By this we have finished with the bridge wave rectifier experiment.
At MSR UAS, we spark your imagination unlike any other.